Question 1. Prove that AFE and DAE are equiangular. So let's just highlight these triangles. What have we got? We're looking for, if I take them out again, I'll label these angles number 1. Number 2 here, this length FE is 5. I'll put in black the numbers of the triangles. This one 3, this one 4. And we can see here, this is a straight line, so this has to be a right angle. So that's what we start with. The angle AED is equal to 90. The reason why it's a straight line, the other side of it's 90. We can say that 1 plus 3 is equal to 90. It's the corner of a rectangle. And we can also say that 1 plus 2 is equal to 90 because there's 3 angles in the triangle, and if one of them is 90, the other 2 are 90. So therefore, 3 is equal to 2. And if 3 is equal to 2, therefore the remaining angles must be equal. And the remaining angles are 4 and 1. 4 is equal to 1. Therefore, equiangular. The marking scheme for this part of the question was 0, 4, 5, 10. 0, 4, 5, 10. If you identified one common angle, you got 4. For 5, which you consider a high partial credit, identifying 2 common angles. Now, if you identified 2 and couldn't say the third was the same, well then, God forbid. So obviously the 10 marks is fully correct. You don't need me to write that down. So 1 common angle 4, even getting the right angle was worth 4 out of 10. 2 common angles 5, and then obviously 3 common angles 10. So mark yourself on this question. Part 2 of this question, find AD, the top side here. Let's call it X. So this is similar triangles. So we can say that X, let's start with X, we're looking for X. X over the equivalent side in the other triangle is, well, this one's opposite the right angle, so we don't need the number, so it's going to be this side here. And you should see that if this side is 12 and this one is 5, based on your knowledge of right angles triangles, that one is 13. You could use Pythagoras, but you don't have to show your work for that part. So that's equal to, now we have, the only other side we have in this bigger triangle is the 12. And what's the equivalent side in the other triangle? Well, it's from number 3 to the right angle is the side 12. So 3 was equal to 2 up here. So the side 2 to the right angle in this one is 5. So we're going to have 5x is equal to 12 times 13. So x is equal to 12 times 13 divided by 5, which if you type into your calculator, you're going to get 31.2. The marking scheme here was 0, 2, 4, and 5. For getting 13, to start, you needed to get 13 to start it. For having just one set of corresponding sides, one set, so like this guy on its own or this guy on its own, was worth 4, one set of corresponding sides, and obviously to get it fully right was worth 5. Easy enough to mark. Part 3, AFE and AGB are similar. Show AB is 36. Let's shut these two triangles down separately. AFE is the small one. AFE, where the diagonal was 13. This one was 12 and this one was 5. So this is the angle we're going to need. And AGB is the bigger one down here, AGB. And we have this side being 39, the 12 and the 27 added together. 39, we need that. So this one 39, opposite the right angle. And we're asked to find AB. AB is the one along the side here, you can see, along here, AB. So let's call that one X and start with that one, X. So X over, in the other triangle, this angle at the top here is the same. I know the triangles look different, but this is the same. So from the right angle to the dot will be 5. Sorry, from the right angle to the dot will be 12. So that's equal to the only other side we have in this triangle is the 39. And from the dot to the blank, or the side opposite the right angle, is 13. So you can see there 39 divided by 13 is 3. So x would have to be 36. You could cross multiply and divide if you wanted, but at this point, x is 36. The marking scheme here is particularly generous, 0, 2, 4, 5. For getting the 39, for adding 27 and 12, you got 2 marks. One set again, same as the previous one. I'll just draw an arrow from the 4 up to this part. One set of corresponding sides, either this one or this one was worth 4, and then fully correct was worth 5. Part 4, you're asked to find the area of quadrilateral GCDE. I'm going to jump back up. GCDE is this guy here. Okay, so there's multiple ways to do this. I can definitely see we've 2 triangles here. So we get the whole area and take away the area of the red triangle. I'll do a green one, the area of the green triangle. I'll just draw it on the inside so you can see it. So this one. So the area of the whole thing minus the red triangle minus the green triangle, and then because this is in both of them, we'd have to add back on that little triangle there. So in the red triangle, I can write, I'll try and fit it in here just to so ADF. The area of that triangle, half the base, well the base is x, which we got to be 31.2. And the perpendicular height is where the right angle is, so it's 13. So that's that one. We want the area of this triangle ABG. Now I don't have this side here, the perpendicular height, but I do have, I'll just sketch it here. I need this one. I have the 39 and the 36 we got to be AB. So just type into your calculator half the square root of 39 squared minus 36 squared, and that will give us 15. So half 36, which was the AB side, 36 by 15. We'd have to add back on the area of, I'm going to shade it in here, this triangle, because it's a crossover. So the base, well, the base is, what was that side, 5, and the perpendicular height was 12. So half 5 by 12 or 12 by 5. So it's the total area, which was 31.2, and we got 36 for AB. So 31.2 by 36 into the calculator, and then minus this guy, and add back on this guy. And if we do all that, we're going to get 680.4. So hopefully it's not too messy up here and you can see the answer. Now the marking scheme, getting the area of one of the triangles. One area was worth 2. Getting 2 areas was worth 4, but not finishing it. And then 5 for fully correct. So a 25 mark question. Question 2 is my prediction for the circle question this year. This type of a question, they could give a different number here for the 2k, but this type of question could come up this year. The tangents to the x and y axis, this circle, and the line x plus y is equal to 2 is this one here, and x plus y is equal to 2k is the one on the right. Find the value of k where k is greater than 1. So the key to this question is the understanding that when we have x and y axis as tangents, this is going to be xx, which is also equal to the radius. So if we draw a line from here to the origin, all the x and y values along here are the same. So this is the line x is equal to y. And if I can get the point of intersection between these two lines, it'll help me find the value of this little sector in here. So let's use simultaneous equations to find the point of intersection between these two. So the black line is x minus y is equal to 0, and the blue line is x plus y is equal to 2. 2x is equal to 2, so x is 1, so y is 1. So this point here is 1, 1. So if I drop my line down like that and do a little right angle triangle here, let me just write it here. This value is 1, this value is 1, so you guys know this is the square root of 2. Now if I just change the color, if we come down here and look at this red triangle, I wanted to go on the inside here so you can see it. we're going to have my radius obviously going from here up to the center. It's the same as this side over here, the radius, and similarly the radius will be along the bottom here. From here to here has to be a radius, and this line in here is a radius plus the value that we just got, which is √2. So now I have another right angle triangle with an OR, an OR, and an OR plus √2. So this will enable me to solve for OR. So OR squared plus OR squared is equal to OR plus √2 to be squared. 2OR squared is equal to OR squared plus OR √2 twice, so 2 √2 OR plus √2 squared, which is 2. So bringing everything to the left, I'm going to get 2OR squared minus OR squared, which is just OR squared, minus 2 √2 OR, minus 2 equals 0. And if you want to just type this into a calculator, you'll get a value for OR using the quadratic formula. If you're not confident, just type it into the calculator. Let's do it out here. Minus b is 2 √2 plus or minus the square root of b squared, 2 √2 to be squared, minus 4 by a, which is 1, by c, which is minus 2, and then all over 2 by 1. So we're going to get 2 √2 plus, what's the square root going to give me? 4 by 2 is 8, and plus 8, so it's 16 over 2. I'm going to have 2 √2 minus the square root of 16 over 2. So it's going to give me 2 √2 plus 4 over 2. So the 2 divides into both of them. So we're going to get √2 plus 2, or √2 minus 2. 4 divided by 2 is 2. Now you can see this one here is going to be less than 0. So we can have a radius length less than 0. So the radius must be 2 √2. 2 plus √2. And we use a translation here to jump from, we're jumping from this point to this point. We have these two values. So we're going to be jumping the same distance to get to here. I'll do this up in the top right. So we're at the point 1, 1. We're jumping to the middle point, which is √2 plus 2. Now it's √2 plus 2 and √2 plus 2. Obviously, we don't need both sides of it though. So what's happening between 1? How much am I jumping by here? I'm jumping 1 to get to 2, and I'm jumping √2. So I have to add on 1 plus √2 to get to my next point. That's the same jump. I'm jumping 1 plus √2. So I'm going to get 3 plus 2 √2. So that's going to be, this point here is going to be 3 plus 2 √2 and 3 plus 2 √2. And we could sub that in here. We want to get a value for x, but you can see what it will be. So we're going to get x plus y is equal to 2k. So if you just sub the values in, you might be able to see the answer before this, but 3 plus 2 √2 is x, so is y. That's equal to 2k. So 6 plus 4 √2 is equal to 2k. So k just divided by 2 is equal to obviously 3 plus 2 √2. So that's your value for k. The marking scheme here, it was a full 25 mark question. So 10, 15, 20 and 25 were the 4 potential marks. For 10, to get the point 1, 1 as the point of intersection was 10. To get one part of the radius was 15. Sorry, the radius was 15. To get the point on the line x plus y is equal to 2k, so that's 3 plus 2 √2 point. And then finally, if you got that, you should have got the 25 to state k equals obviously full marks. So full 25 mark question. As I said to you guys before, this is my prediction for this year. A question where the circle, x and y axis are tangents. The 2k, if it was 4k, obviously you just divide by 4 here at the end. Could be 6k, could be 8k. It's unlikely to be an odd number, but it could be. So the same question can be asked in several different ways. Next question, it's a trig equation. Cos 3x is equal to minus √3 over 2. So on your calculator, if you type in inverse cos of √3 over 2, you're going to get 30 degrees. So the cos of 30 degrees is √3 over 2. So what we have to know is where in our unit circle is cos negative You've done this hundreds of times. Cos is positive in this one and this one. So we draw our 30-degree angle in here and our 30-degree angle in here. And then we look at, well, what actual size are those angles? So this one is obviously 150. And in the other, I'll do in green, going all the way around, 180 plus 30. The green one is 210. So 2x is equal to 150, 210. Now add 360 onto each of these, and we're going to get 510 and 360, 570. And if we add 360 on again, we're going to go above what the solution is looking for here. X is between 0 and 360. So x is equal to 75, 105, 255, and 285. The marking scheme here was 0, 7, 13, 20. So pretty generous again, which you'll find a lot of these questions on the exam will be generous. So for 7, if you got to 30 degrees, you got 7. For the high partial credit, the 13, you got 2 values. So normally what people do, they get these 2 and leave these 2 out. So 13 was 2 values and 20 was all 4. Next question, you're given this diagram. Apologies for the drawing of the diagram, but we're asked to find the perimeter of the squares if this process is continued indefinitely, where the lines are drawn to the midpoints. So we can see here that this side length is going to be a 1 and a 1 and a 1. So we look at the triangle down the bottom here. So this red one is going to be, we've had this already today, a root 2. So the perimeter of this square is going to be 4 root 2s all the way around. So let's write that. So the perimeter of the first one is 8. The second one is 4 root 2. And there's a kind of tip in the question, indefinitely. Now that's not giving us a value for n. So we have s n is equal to a times 1 minus r to the power of n over 1 minus r. But that's when we have a value for n. This indefinite is the infinite series. So the sum to infinity is just a over 1 minus r. So we need a, which we have, and we need the ratio. Well, let's get the length at the next side. So if we have root 2 being the red one, I'll just change color. This black one, then we're looking for the length of these ones. So this is going to be root 2 over 2, this bit just here, and so is this bit here going to be root 2 over 2. So to get this one, it's Pythagoras again. So the square root of root 2 over 2 squared plus root 2 over 2 squared is going to be equal to the square root of 2 over 4 plus 2 over 4, which is the square root of 1, which is equal to 1. So this is a 1, this is a 1, this is a 1, and this is a 1. So the perimeter of that one is 4. So what's my ratio here? Well, it's term 3 over term 2, or term 2 over term 1. So you didn't have to get the third side, but maybe good maths to do it. So let's just check that they're the same. 4 over 4 root 2 is term 3 over term 2. This is how we get our ratio. That will be equal to term 2 over term 1 if this question is correct, which of course it will be. So term 2 over term 1 is 4 root 2 over 8. So just simplify these down. We're going to get 1 over root 2 there. And we're going to get root 2 over 2. And you guys know 1 over root 2 is equal to root 2 over 2. Because if we multiply this one by 1, root 2 over root 2, we're going to get 2 over 2 root 2, which is 1 over root 2. So my ratio is 1 over root 2, my r, and my a is 8. So 8 divided by 1 minus 1 over root 2 is the sum to infinity. Typing it into a calculator comes out as 16 plus 8 root 2. 16 plus 8 root 2. And the marking scheme for this is a 10-mark question. 0, 5, 8, and 10. So for 5 marks, you got the length of one side of a new square. So to get the first one, that was one square in. The 8 is fully correct substitution into the formula. And how you could do that and not get 10 is beyond me, but it's possible. So 10 fully correct. Next question is this proof of a trig identity, tan. So what is tan equal to? Tan is equal to sine over cos. I think that's the easiest way to do this question. So tan A plus B is going to be equal to sine A plus B over cos A plus B. And if we go to the formula booklet here, you're not expected to remember these things. Sine A plus B is sine A cos B plus cos A sine B. And cos A plus B, and this is where the minus is going to come in, is cos A cos B minus sine A sine B. And you guys remember doing this before. How do we get a 1 in this position here? This 1. We'd have to divide it by cos A cos B. So what we do is we divide everything by cos A cos B. So sine A cos B divided by cos A cos B. You can see what's happening here. Plus cos A sine B divided by cos A cos B over, I'm just going to write 1 there, and then, well, maybe just write cos A cos B divided by cos A cos B. Probably better maths to just show your work here. So minus sine A sine B over cos A cos B. So what are we left with? We're left with sine over cos, which we said at the start was tan. So we're left with tan A plus tan B divided by 1, this guy, 1 minus sine A over cos A is tan A, and sine B over cos B is tan B. Tan A plus tan B over 1 minus tan A tan B. So we have what we were looking for. Market scheme here was 5, 10, 15. So for identifying, some form of sine over cos was worth 5. For some correct substitution into this was worth 10. And for fully correct all the way down was worth 15. So quite a generic marking scheme there. Some correct substitution can be a very small amount, or it could be quite a lot with one small mistake at the end. But 5, 10, 15 for this question. So another trig identity, this time it's sine. What sine of what is equal to root 3 over 2? Well, the sine of 30 is a half. These are the ones you all know. And the sine of 60 is root 3 over 2. Where is sine positive? Obviously, we've got a 60 there. CA, your S is positive in here, so 60 in here will give me an angle of 30 plus 90, which is 120. So 3x is equal to 60. 120, we have to get an answer of between 0 and 360, so keep adding on your 360. So 360 and 60 is 420. 480 will be the next one. Now we're dividing by 3 here. That's only going to be 160, so we do need to go up another 1 or 2. 360 and 420 is 780, and 360, and we're going up another 60, so that would be 840. Dividing all these by 3, we're going to get 20. We have 40. We have 140, 160. It's going to be 260 and 280, and you can see if you went up another 360, you'd be adding 120 on minimum, which would get it past the 360. So these are my 6 solutions to this question. The marking scheme. This one was 5, 10, 15. Previous trig was 20. Depending on the curve that year, they made it a little bit easier. So 5 is to get your 60. 10 is for 2 correct values. And 15 was for all 6 correct values. So make sure to get all solutions. Sorry, this was not 5, 10, 15, it was 5, 7, 10, but the same rules apply. There's the ball bouncing question. So Mary throws her from a height of 2. So it goes back up 3/4 to the previous side. So just set up your calculator. 2 by 3/4 is 1.5. 1.5 by 3/4 is 9. 1 and an 8, so 9 over 8. And then we're going to get 27 over 32. And then we're going to get 81. You can see the pattern here. 81 over 128. There were 10 marks for this part. It was 0, 5, 7, 10. The mid and low partial credits. 4 correct. 2 correct. And all, sorry, this was 2 correct, 3 correct, and all 4 correct. All 4 was 10. Find in meters the total vertical distance up and down the ball that travelled when it hit the ground for the 5th time. You just add them up. This is 1.5 up and 1.5 down, so 1.5 twice. You can do that. This one is going to be, what is it, 9 over 8 twice. And just type them all into your calculator and add your 2. I think in part C, we do need to use the a over 1 minus r geometric sequence indefinitely. So why don't we set that up now? We're not taking in the 0 part, so we're taking in a as 1.5. The ratio we were told was 3/4. And because it's up and down here, we're going to have to multiply this by 2. So from this point here, it's 1, 2, 3, 4. N is equal to 4. And we'll add the 2 on at the beginning. So we're going to have a times 1 minus r to the power of n over 1 minus r. That's my geometric series. So 1.5 by 1 minus r is 3/4, 0.75 to the power of 4 divided by 1 minus 0.75. So if you type this into your calculator, you get 4.1015, 4.101. If we multiply that by 2, we're going to get 8.203. I don't think it asks for it as a decimal, does it? Fraction form, okay, fraction form. 8 and 13 over 64 is what comes up on the calculator. And then we're going to add 2, the 2 at the beginning, so 10 and 13 over 64. Another 10 mark question. It was 0, 5, 10. So 1 correct part, 1 part correct, or all of it correct. So a tougher marking scheme there. 5 or 10, nothing in between. So the ball bounces indefinitely in part C. This question was 0, 2, 5. So it's going to be 2 plus twice the infinite series, which is a over 1 minus r. So when you have a bit of knowledge about these infinite series, once you see the word indefinite, you're using sum to infinity. We've seen that already in this test. So 2 plus twice, a was 1.5 divided by 1 minus r, which we have already, 0.25. And typing this into your calculator, you're going to get, well, 1.5 divided by 0.25 is 6, times 2 is 12, plus 2 is 14 meters. So some correct substitution 2, fully correct 5. So proof by induction, 15 marks. The Moivre's proof, another recommendation to be ready for in the 2020 exam. So proof by induction, we show it's true for n is equal to 1. So we're going to get cos of theta plus I sine theta to the power of 1, which is equal to the cos of, if you want to write the 1 in, 1 theta plus I sine 1 theta, which is true. Assume true for n equal to k. So we're going to get the cos of theta plus I sine theta to the power of k. And now we're going to show true for n is equal to k plus 1. So we're going to get the cos of theta plus I sine theta to the power of k plus 1. Which we're always going to use the assumption. So this is the k part. So if we break this up into the cos of theta plus I sine theta to the power 1 times the cos of theta plus I sine theta to the power k. So using this assumption, which we probably should have written as cos k theta plus I sine k theta, we're going to bring that down, and we're going to have the cos of theta plus I sine theta multiplied by the cos of k theta plus I sine k theta. We multiply this out, we're going to get cos theta by cos k theta plus cos theta by I sine k theta plus I sine k theta by cos k theta, and we're going to have plus I squared, so minus 1 minus sine theta by sine k theta. So what we need to do is bring the two real parts together, the parts with no I, and then with these two guys both have an I in them, they're the imaginary part. So we have cos theta cos k theta minus sine theta sine k theta. Now, have we already seen today cos A cos B minus sine A sine B? And then we have plus I times cos theta sine k theta, that's this one here, and then sine k theta. Well, we do the I have an extra k theta in here, don't I? Yeah, this one should just be theta. I sine theta, so it's I by the cos of theta. Sorry, I'm mixing myself up. This is k theta, and then we're going to have plus. Now it's the theta first and the k theta second, so your A and your B. So sine theta cos k theta, and that's cos A sine B plus sine A cos B. So let's write that out. We have cos A cos B minus sine A sine B plus I times cos A sine B plus sine A cos B. So go to your formula booklet always within this, make sure you write out the correct identity. So cos A cos B minus sine A sine B is cos A plus B, which is going to give us the cos of theta plus k theta cos A sine B plus sine A cos B is written as sine A cos B plus cos A sine B in the tables, and that is equal to sine A plus B. That's an S, which is going to give me plus I times the sine of theta plus k theta. And if you factor out your theta, you're going to get cos of k plus 1 times theta plus I sine k plus 1 times theta, or theta times k plus 1, but the way it's written here is the n is first. So we've shown it's true now, and we just write out the end of this, therefore true for k plus 1, therefore true for all values of k. So let's look at the marking scheme for this one. A very generous 5 marks for showing it's true for n is equal to 1. That was 5 of the 15. To get 7 marks, you had to have ridiculously one or the other of these two steps written out like this. This one, or this one. I probably should have written the k plus 1 times theta here equals that. What we should have shown this to be is cos of k plus 1 times theta plus I sine k plus 1 times theta. Probably should have written that out. You didn't have to, but you know, good math. So that up to there will be 7. To get 11 marks, the high partial credit, you needed to prove In the market scheme, it says the high partial credit, you use step P of K to prove step P of K plus 1, but with an error. So sum of this correct will be 11, and then fully correct 15, but minus 1 if you don't write out this part here. Second part of this question, hence or otherwise find minus a half plus 3 over 2i to the power 3 in its simplest form. So we know that this is the cos of theta plus I sine theta. So we need an angle that's negative for cos and positive for sine. C-A-S-T. Well, they're both negative in here, so it can't be in there. Cos is positive in here, so it's not that one. They're both positive in here, so it's not that one. And in this one, you can see sine is positive and cos is negative. So our reference angle, what is it? So what angle gives a cos value of a half? The cos of 60 is equal to a half. No, it's not. The cos of 30. No, it is. Cos 60 is a half. Doubt myself here. So we're looking at, let's just do the unit circle again and draw that angle in there, 60. So we're looking at an angle of 120. Or pi over 3 being 60 times 2. So here we have, well, the radius would have to be a 1 here. There have to be a 1 in front. So we're looking at the cos of 3 times, we know that power comes in front, 2 pi over 3 plus I sine 3 times 2 pi over 3. So that's going to be the cos of 360. The cos of 360 is at this point here, 0.10. So the cos of 360 is 1, and the sine of 360 is 0. So this is going to be 1 plus 0i. And the marking scheme there, modulus or argument correct, 0, 4, 8, 10. So modulus or arguments are getting the correct angle. Or modulus, so you can see the modulus is 1 in this case. So 4 marks if you got the modulus correct. Seems a bit easy for those 4 marks. Some correct manipulation also 4 marks. And apply the Moivre correctly with incorrect modulus and argument, 4 marks. High partial credit for getting to here, that's your 8. And then obviously 10 for simplifying. 8 to here, 10 to here. Last question, proof by induction, 15 marker. Prove by induction that 8 to the power of n minus 1 is divisible by 7 for all n is an element of natural numbers. So when n is equal to 1, we get 8 to the power of 1 and minus 1, which is equal to 7, which is divisible by 7. So yes, assume true for n equal to k. So you get 8 to the power of k minus 1 divisible by 7. That means that 8 to the power of k minus 1 is equal to 7 times a number. Let's call that number a. And this will help me get the 1 over to the other side. So 8 to the power of k is equal to 7a plus 1. So show true for n is equal to k plus 1. So we get 8 to the power of k plus 1 minus 1 would have to be divisible by 7. So 8 to the power of k plus 1 is 8 to the power of k times 8 to the power of 1, and we have the minus 1. And if we fill in for my assumption, which is always what we need within these questions, 8 to the power of k, I'll put the 8 in front, is 7a plus 1. And the minus 1 is still there. So multiplying this out, we're going to get 56a plus 8 minus 1, which is 56a plus 7. And we should be able to, we can factor out a 7. We have our proof. So is that 7 times 8 is 56? So that's pretty much it done. Therefore, when n is equal to k plus 1, it's divisible by 7. Therefore, shown true for n equal to 1. This is probably what I should have written for the Moivre proof as well. Assume true, and they do want this at the end, or it's minus 1 for n equal to k proven true for n is equal to k plus 1, therefore true for all values of k. Okay, so the marking scheme here. Again, give away 0, 4, 7, 11, 0, 4, 7, 11, 15. So for 4 marks, Sean P1 was true. That one there. 4, 7. Either of these steps, either that one or this one here. Getting that one correct or that one correct was 7. 11 was some use of the n is equal to k to show n is equal to k plus 1 true. So sum of this, sum of it is 11. And then 15 for the whole lot, and minus 1 if you don't write this bit down the bottom. So add your scores up, correct your test, and send me the result.